Hello guys, welcome back to the Universe of Tech Hub. In this tutorial, we will learn about what are the problem solving techniques in data structures and algorithms. First, we need to learn problem solving techniques in data structures and algorithm. In data structure and algorithm, problem solving techniques is refers to a strategies and approaches used to break down a problem and find an efficient solution. Each technique is typically applied to a specific types of problems. It is all depends upon the types of problems, and mastering these techniques is essential for developing a efficient algorithms. Here is an overview of the most commonly used problem solving techniques in DSA. First, we will learn about why problem solving techniques are essential in DSA, data structures and algorithm. They essential in efficiency and scalability and reduction of complexity. Breaking down problems, complex problems can be difficult to solve directly. Techniques like divide and conquer techniques or backtracking techniques and allow you to break the problem into a smaller and manageable sub problems which are easier to handle. For example, merge sort like that. And next one is it is faster problem solving. So that is we need to use the problem solving techniques. Like for example, pattern recognition. DSA problem solving techniques often involves a recognizing a patterns or similarities with known problems. For example, if you recognize that a problem is similar to a knapsack, and optimized search and sorting techniques like binary search, hashing, these are allow you to solve the problems much faster than linear approach. So that is the reason we need to use problem solving techniques in DSA. And also improve the analytical thinking and structured problem solving. Like DSA techniques encourages the structured problem solving which can improve your logical thinking and analytical skills. The step by step process of breaking a problem down into the smaller components, choosing an optimal strategies like that, and by mastering the techniques you can solve problems more efficiently in terms of time, space, like that, and recognizing the patterns in different problems types and apply the known techniques like that, and handle the large data sets and complex real world problems, and improve your analytical skills and prepare for coding challenges, interviews, and competitions. These are all the advantages why we need to use problem solving techniques in DSA. Next, and also used in the handling a complex data structures. So that is we need to use the problem solving techniques. We need to move on to the what are the list of problem solving techniques. First one is brute force. What is brute force? The techniques involves checking all the possible solution to a problem. It is simple to implement but can be inefficient for large inputs. First, we need to learn what is brute force. Brute force is a technique. It involves checking all the possible solution to a problem. It is a simple to implement and but can be inefficient for a large inputs. Next, it when to use the brute force. Brute force is used when the input size is small or when no other efficient approach is unknown. So that time we need to use brute force. The size is small, so that we need to use the brute force. And like example for linear search and finding all pairs of numbers that add to the target or checking all the substrings of strings. These are all the examples for uh, brute force. We need to use the brute force. Next one is divide and conquer techniques. Everyone knows divide and conquer techniques. Divide and conquer technique is a process of dividing the problem into two or more smaller subproblems, solving each subproblem independently, and then combining their solution. For example, merge sort like that, where it is used uh, when we need to use the divide and conquer is it is helpful in problems where the solution of smaller subproblems can be merged to form the final solution. So that that situation we need to use a divide and conquer. Divide and conquer is a helpful in problems where the solution of smaller sub-problems can be merged to form the final solution. For example, binary search and merge sort and quick sort, these are all the example for divide and conquer technique. Next one is greedy algorithm. The greedy approach involves making a locally optimal choice at each stage with the hope that these choices lead to globally optimal solution. The greedy approach is involving making the locally optimal choices at each stage with the hope that these choices lead to a globally optimal solution. When we need to use the greedy algorithm, this technique works best for the optimization problems where the local decisions lead to an overall optimal solution. For example, activity selection problem and Uffman encoding and Discras algorithm. Next, these are all the greedy algorithm, how when we need to use and what are the examples in greedy algorithm and definition of greedy algorithm. Next one is dynamic programming. Dynamic program is used to solve the problems by breaking them down into the overlapping subproblems. It stores the result of subproblems memorization to avoid redundant computations. Dynamic programming is when we need to use the dynamic programming is useful when the problem has overlapping subproblems and the optimal substructures. The optimal solution to the problems can be constructed from the optimal solution to its subproblems. So that we need that is the time we need to use the dynamic programming. There are two types in dynamic programming. First one is top-down approach. Second one is bottom-up approach. In top-down approach, using a recursion and memorization. In bottom-up approach, using a iterative approach to solve the problem in a table. For example, for dynamic programming is Fibonacci and Fibonacci sequence and longest common subsequences (LCS) and knapsack problem like that. And next one is backtracking. The backtracking is a refinement of a brute force where you explore possible solutions incrementally and backtrack a solution as soon as it is determined that the solution cannot be extended to a valid one. So this is what is backtracking. The when we need to use backtracking is used when trying to find all the possible solutions and you want to discard partial solution that cannot lead to a complete solution. For example, we all know about for problems and Sudoku solver and subset sum problem like that. We need to use a backtracking. And next one is recursion. Recursion involves a function calling itself to solve a smaller instance of the problem. It's closely related to the divide and conquer and backtracking. The use case for recursion is problems that can be broken into a smaller. It's similar to the subproblems. The recursive tree traversal, combinators, and problems like a tower of an eye, like that. Example of DSA tree travels in order, tree pre-order, post-order, factorial computation. These are all the examples for recursion. This is all about what is problem solving techniques, why we need to use a problem solving techniques, why problem solving techniques are essential in DSA, and list of problem solving techniques. There are 6 types. Each one we explain in detail next class. If you like this video, please don't forget to subscribe, like and share and comment in this video.